Okay. Good evening, everybody. And if you are hearing me, say hi, or you can unmute and say hi, or good evening, or you can say in the chat. I would like to know that I would like to know that you are hearing my voice clearly.
Good, sir. Audible.
Hi, sir.
Okay, that's fine.
Meghana.
Yeah, I could hear you. I could see you also. It's fine. Very nice. So, okay, so let us start the day. And as usual, on the Eastern Academy welcomes you to the second day of the session. Today we are going to discuss about, yesterday we have discussed about generally what is programming. What I have told you, the steps are enough to understand programming. I can give you a lot more problems. I'll do that. I'll slowly start giving you, but I'm not going to stop with these 5 days. I will proceed beyond the 5 days. And I wanted everybody to write it. Okay. And if you're not able to write it, this is English. Yesterday problem, what I given to you is a very, very simple English problem. It is nothing to do with computer at all. When we cannot solve the English problem, a normal problem, then we cannot go to computer. I told you not only English. If you know Tamil, Tamil. If you know Hindi, Hindi. If you know Malayalam or Telugu, whichever language you know, you write on that language. That's all I told. Try to understand what I given an example also. Yesterday I conducted a class and I sent you the recorded lessons. Now we are going to discuss about the computer languages generally, not worrying about only a specific language. What the computer languages, what they do actually. Okay. So yesterday we have stopped at this place. We have discussed about the very simple problem. Okay, so we are reducing the blue to 10. Then we are going to, this is simple. Okay, then I gave a problem yesterday. Okay, and sorry, today. Yesterday I couldn't send it because of some issue with Google. I didn't know that, so that's it. So today only I managed the problem. So, oh sorry, this is yesterday's thing. Yeah, this is what the problem I given today. That is, I ask you to move 26 to red and 12 to green and 0 to blue. That's same. You're just moving 3 values while starting. Then red is bigger than green. So I told you the difference. When the difference becomes 0, when it is bigger. Okay. Then if it is yes, then increment green by 1, blue by 1, then go to 3. Oh, sorry. It's go to 2. I forgot to. I'll change it. That's all. Sometimes we happen to cut and paste. Okay. So go to 4. All cut and paste mistake. So go to 4. So check if red is bigger than green. No, keep on doing it. The green will be, keep on incrementing 14 times to reach 26. By the time blue will become 14. So then when red and green are equal, then it will come out. That time the answer will become. This is what we discuss. Okay. So this, if you could get it, fine. Or normally I do not give solution. Since this is the first session, I just wanted to know you to understand this. Anyhow, this recorded video will be given to you. You can see at home how the solution is. Okay, if you could, a lot of people have solved it. It's fine. It's a very simple problem for most of the people. Okay, for yes. Tell me, Jagannath. Hello, Jagannath. You have raised your hand. Nothing? That's fine. I'll proceed. Raising a hand means you want to break. That's the meaning. Okay, so the trick is, we had a discuss here and we had a board and we gave all the instruction to the human being. Now let us do one thing. Anyhow, we are not going to access the board. Our instructions are going to the human being. What we do is we will put both of them as in a black box. Let us not worry about what he is doing. Okay. Now we will try to give him the input, and he will give you the output. That's enough. So we do not have to worry about whether he write on board or notebook or whatever it is. But as long as he follows our method, it is fine. But we know that what is inside. We know that there is a human being. We know that. That case, forget it. Let him be as a black box. Let him be a box. So we give them the input to him, and then we will take the output. That's fine. Now, see here, I do the same thing, but only one small change here. Everything same, but only one small change. When we return back, now we have got a same thing, but instead of human being, I put a box. And instead of a board, I have something else. Hello?
Hello?
Yeah?
Now you're there?
Hello? No sound? Is everybody hearing or only you? Hello?
Hearing, sir.
Anybody?
Hearing,
Yeah.
sir.
So everybody is hearing.
Yes, sir.
Let me see. He is not getting the sound. All are hearing. Hello?
Yes, Balaji sir. How are you?
Sorry, there was a call. Okay. So I think Jagannath is the only one.
Sir, maybe network issue.
Okay, whatever it is. Okay, that is fine. Let us proceed. If only one person, then I cannot. It's not my problem. Okay, that is fine. Okay, click join. I myself don't know. A lot of people, you people don't know. I don't know anything. I'm having one setup. I work on it. That's all. Thanks. If anybody would support him, it's very good. Okay, so see, the biggest problem with us is we would like to think what I told yesterday that this human being is different than the computer. No. It's both. See, that's what I'm trying to say. These both are same. So there's no difference. See, whatever we are given this instruction and the human being and the board, this is what we are going to discuss. But only thing is slightly in a different way. What is a different way? Where we put a black box, same input, same output, but now we are replacing with the human being. Assume there's a human being. Then we have replaced with the red, blue, everything with the same color, but we are given a number 0 to 19. That means there are 20 lines are there. So I have a 20 lines where I can write 20 numbers. Previously I had only 3 boxes. Now I have 20 boxes. Am I right? Now I have same thing. I have an input and I have output. Same way, if we take a human being, I have a brain. Now I call this a CPU, Central Processing Unit. Now your brain does not directly take your sound. It uses your ears. Same way, your brain does not put the sound outside. It needs a mouth. Same way here, I take the input device and it goes to CPU. Then it gives the output device. Now we take this instruction. 5 to red, 7 to green, red plus green, blue. That is what we have written, our program. Am I right? So this is what the program we have seen yesterday. But unfortunately, right now, in the new board, we don't have a red, green, blue. We have instead of that 0 to 19. Understand? Previously, we have a red square box, green box, and blue box. So if I ask a human being to write into the red box, he was writing into the red box. When he asked him to write into the blue box, he was writing into the blue box. But now I don't have red or green. I have only 0 to 20. All of them are the same color. Now the thing is that when I tell him red or green or blue, he cannot do that. So what is happening is our translator is slightly intelligent. What he does is he converts all these numbers into the language which our CPU understand. You forget it. This will come later. Now, before that, what he does is he takes these three, red, green, and blue. Then the translator, what he does, he creates a table. See that? What is the symbol now? Red, green, blue. But in the memory, you have 8, 12, and 17. 3 location.
Excuse me.
Yeah?
Sir, are you sharing the screen, sir?
Oh, yeah, I'm sharing the screen.
Uh-huh.
Yeah. I'm sharing the screen.
Okay, sir, fine.
Anybody is watching the screen or not? Hello, anybody, please?
Sir, showing.
Another
We
problem.
can see the
Watching,
screen.
sir, watching.
Screen is
Okay,
visible, sir.
Oh, thank you.
Okay,
Thank you.
fine.
Oh,
Okay, sir, fine.
hey,
Thanks.
please do not mistake me. If you have any problem, raise it, because all the remote classes, these problems used to happen. Okay.
Yes, sure, sir. Thanks.
It's not
Thanks.
a class.
Sorry, sir.
So that's the thing. Okay, no problem. No, sorry. Even I did so many times. Okay, these are all happens.
Thanks.
I told you, na, don't trust electronics, because I'm an electronics engineer for 34 years. Okay, any transistor goes bad, heating, misbehaving, things will go bad. Out of billions of transistor, one transistor could spoil the whole computer not working. Okay, I don't know where the transistor is. That's the problem. Okay, now you see here, as I mentioned to you that when I give this previous problem to the translator understands red, green, and blue, which right now it is not there. So what the translator does intelligently, he has taken the table for everything. He convert number, because he knows that we don't have a red box or green box or blue box. Then actually I've written for not to confuse you 8, 12, 19, but the translator write into binary, because our computer accept only binary. There's nothing called decimal. Everything is binary. Then what happened? This is what the memory location. Now you see that when you say red, it is pointing to 8. When you say green, it is pointing to 12. When you say blue, it is pointing to 17. Next time onwards, if you tell the CPU, hey, write 10 on red, he will write it on the location 8. If you ask him to write 20 on green, he will write it on the green. So all this location, red, green, blue, all of them are having equivalent numbers. This is called symbol. This we call it as a symbol table. That is, every symbol what you use is being converted to the table by the translator. The translator will give you every label or every symbol, equivalent number. That number is a location number in the memory. Okay. Now, or a board, whatever it is, you don't call it, say, hey, if you have a notebook, you have lines, assume anything. So I literally don't worry about the box. Don't see, as long as you do not get confused too much, you will solve all the problems. The moment you want to go everything, you want to know details, then you will never solve the problem. That is not your that is a problem. Okay, now let us try to get into the thing. So what we have done is, our same program, the translator understands red, green, blue you are using. So for equivalent, he has given numbers, and then he is giving it everything. Now let us see. I have written now 25 to red, and I am writing A. And forget about this, also another number, like a hexadecimal, like a decimal binary. There is another type of numbering. Forget this. Those people don't confuse. So now various type of numbers I'm taking, I am giving to translator. Let's see how he is translating. See that 25 means here 11001. That means 25 in binary. Then red he knows that already. The previous we have seen that red means 8. So what he has, red means 8, 12, and 17. So what he has done, red means 12. So he is writing 25 into red. And A means is an ASCII. Forget it. The translator, see, what I am trying to tell you is that what I am trying to convey is very clear. the translator convert everything what you write in English into binary number, because your CPU accepts only binary. He never accepts anything else. Let us say you are saving your MP3 file. My video is coming to you. You are watching video. Everything is binary. How these things are happening? That's a trick. For that only we are here. Basically, the more you understand the programming, the more you will really realize the this how the computer works. So without that you cannot. So if you would like to understand the computer architecture, if you like to understand the how the computer works, a knowledge of programming is must, because 99% of the computer is programming. You without that nothing will move on the computer. Okay, people can say that I know hardware and everything, but hardware is only connection. But who makes it happen? That is why we are here. So try to discuss with me as much as possible. If you don't understand, always give me a word. Lot of people are talking to me in WhatsApp. I'm quite happy. So I like this trend. So don't see the problem is somebody is available to you, give you the problems. Use it as much as possible. That's what thing. Now, after I convert this, what is happening is, see here, that's what your when I convert when it's given to CPU, how the CPU writes, you see here, at 25 means 001101. Forget it. If you don't know how to convert a decimal to binary, oh, don't worry. See, I'm writing at 25 location 25, and I'm writing this to the location 11, and I'm writing the blue that 0x56. But understand one thing, I'm writing 25 on one location, I am writing A on one location, I am writing 0x56. But whatever you write, I don't mind. For me, for the computer, everything is numbers, it stores. This is a very critical for us. Now, we'll go to the next one. Now you see that I've written red plus green is equal to blue. That means that I'm adding red and green. I'm trying to put the number into the blue. See that our man is converting this. What you are doing? Addition. Okay. Then this number 000111. That is what your CPU understand. He does not understand your plus symbol or addition. For addition, there is a number. Then red is at 8 and green is at 12 and blue is at 17. So he is trying to read from 8 and read from 12 and writing it to blue. Don't try to understand the binary. Please, I'm telling you that you will get confused. Or if you would like to know that, come to me one day, I'll explain to you how exactly microprocessor is CPU is using the number language. I lived with this. Okay, we have designed the microprocessor CPU, so we know that how the CPU use the number language, which I can explain. But right now, that is not our issue. Our issue is that the translator just convert this into the number. But when I give this to CPU, how the CPU is going to read from memory? See that when he read this instruction, he reads from 8 and put it here. Now what is there here? 25. Then he reads, oh, what is that number? Some number 01000001. Then what is that? We are performing addition. So he is going to add both. See that this is what exactly this. When you write this command, when you write this red plus green blue, what is happening is a translator translates it into binary number, and the binary is given to the CPU. Then the CPU is doing the activity. He is reading from red, for him 8. For you it is 8. Then he is reading from, see, don't see as a 12. This is actually what the name given by you is green. Then after adding the two number, let's say you add 1 plus 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. That's all. It's a binary addition. Then That's what CPU add. CPU does not add your 25 and 15 and dot. He will add only the binary number. So please understand, don't try to confuse the CPU, because you will never understand this binary language, because it's quite tough. We never use it day-to-day life. In our day-to-day life, we use only decimal. So don't try to confuse yourself. Now, then the CPU write the number into the 17. This gets written here. This is what we have discussed now, 3 operation. Understand one thing. This is what most important. What we tried was first, see here. In this, first we have allocated a place called red, green, blue. We have given 3 location. Okay. So we have given location for the 3 boxes. You have used 3 colors, red, green, blue. Then all the 3 are in your notebook or memory, whatever it is. Then you are trying to write a number or a character or a different type of number into the locations what you have assigned. So they were written there. So this is what exactly the meaning. 25 to red means, 25 to red. That is what happening. The red is 8 here and the 25 is here. Actually, this 0 to 20, 19 I have written. That is also not decimal. That is also binary only. Just for you to understand, I have written. If I start writing that also in binary, you will get confused. That's why I have not written. But see, there are only 2 systems. One is for you here, decimal and English. But when you go to the computer, everything is binary. Nothing is, no other, it does not understand anything else. Whether it does not understand your voice or picture or anything, everything is binary. Then how you are seeing picture, how you see a movie, everything. That's all I'm telling you, that if you want to understand everything, be a good programmer, then you will understand. Okay, then you will thoroughly understand how the CPU is doing all these things. Now, then we did about addition. Okay, so we did 3 operation. One is we have allocated for every symbol a memory location. Second thing is we have stored a number in that. Third, I have done it. Okay, this is what I told you, that how it is performing addition. Okay, now you'll be very surprised. You'll be very surprised. All the computer languages in the world, whether you call C, C++, assembly, Java, Python, all are using this method only. Where they differ. Okay, now we have to discuss only one thing else extra. That unfortunately I didn't put the slide. There's something mistake happened. I didn't do it. Okay, I did everything. It's gone. So that is here. After this, we have discussed first. Let me go to the board. And one thing, let's stop right now here. Anybody have any? If you don't understand anything here, please let me know. We have done 3 operations. I'm telling you once again, we have done 3 operations. First, for every symbol, red, green, blue, we allocated a line number. You can call this as a line number. So for you red, for the computer it is 8. For you green, for the computer it is 12. For you blue, for the computer it is 17. The computer means I'm talking about the CPU. Both are same for us. Let's call a computer. Let us not get into the too much of CPU, memory and everything. So now I have replaced a human being with a computer, but unfortunately here everything is numbers. So for all the symbol, we get numbers. Then actually the symbols are in binary only, not this. I have written 8, 12, 17 for you to understand. But actually it will get like this. Red means 0, 0, 0, 1, 0, 0. 12 means 0, 0, 0, 1, 1, 0, 0. Blue means 17, 0, 0, 0, 1. So the computer never understands red, blue, green. It understands 8, 12 and 17 only. Now then what we did, we stored a number on that. This is the second operation. And the third operation is we perform addition. You can do addition, multiplication. If you put multiplication here, instead of 111, there will be some other number. For each and every operation, that our computer have a different name, different number. For us, we have addition, subtraction, everything. Okay, then we discuss how the CPU is reading from the line numbers, the data, then it is performing the operation. It from 8 means red, green, and do the operation. If let me give a gap for a minute. If anybody have any doubt on this, please let me know. Okay, I think I can proceed further. So see, the problem is what I am discussing is very critical. These operations only I'm going to give you lots of problems. Unless you solve the problems, we cannot. I'll draw it on the. Let me go back to the board because I'm very comfortable on the board because this PowerPoint does not reflect my thinking as good. So I'm not much like to speak. I want to put everything on the paper. Then only you can see it. Okay, so now we have seen three things. We have seen red, green. See, don't say that why I'm sticking on to this. There is a reason because these are the very, very critical. Most people, okay, I've written even already a lot of people know C programming and everything. So there or Python everywhere. We don't understand this problem very clearly. That's why I'm telling you that. Please understand. In the first session, we have given them as a boxes. So what we discussed was red box, green box, and blue box. Now we have done a small change. That is, we don't have a green box, red box, everything. All of them are single box, single color. Once again, boxes, but they have 0, 1, 2, 3, 4. Don't mistake me why I'm starting from 0. In computers, we never start from 1. We always start from 0. Then what we had done was we created a table. In the table, we have written red means 8. Sorry, in this case, let us say 1. Green means 2. And blue means 3. That's all. Now, for you red, but actually this side, you don't see this side. Forget about it. So you think that you are writing it red, but actually it is written into 1. If you read from red, it will read from 1. The table will be fixed. Normally, nobody changes the table. This table cannot be changed. If you use any variable, the table cannot be changed. Okay, that's why they call it as a symbol table. Every symbol, there is an equivalent line number is there. These are all line numbers. They are not content. Actually, content is inside. When I say red, actually it's not red. If you say 5 to red, actually you are not writing into the symbol table. In the symbol table, you have a red, which is having 1. Am I right? When I say 5 to red, you are not writing into the 5 here. No. This meaning is, the actual meaning of 5 to red is, you are writing into the 5 to the location pointed by the red. Here. That's the most important to understand. It is not actually red. It is a location pointed by red. This and all we'll discuss later, not now, because I wanted you to be good in programming. So we have discussed. So this one, for every symbol, he allocates a space in the memory. Which location it is? This is called allocation. But here a small confusion, but I'll explain to you, but don't take it serious. That we will use it later. But I have to inform you now. Let us say you decided to construct a house. When you decide to construct a house, if you go to a real estate person, you will ask him, depends on your house. Let's say you have less money and your small family, you will say, hey, I want to have a one bedroom BHK or 2 bedroom. Okay, if you are having a flat, or if you like to have a buy a land, you will say that, hey, I want a 1 ground or 2 ground or 4 ground or 8 ground. Why do you say ground means it's a fixed? For example, ground means 60 feet by 40 feet. In here, in it changes in various places. Okay, it is 1,200, sorry, 2,400 square feet. That means 1 ground. So in our terminology, we know that 1 ground means square feet. So this is what the terminology. We normally say that, hey, how many grounds you have a constructor, man? I have a 10 grounds, 20 grounds. That's the way. Now in our computer, you have a memory. What is your memory in your pen drive? Oh, I have a 32 gigabyte. Okay. Then if you say that, what is your RAM size of your mobile phone? Oh, I'll have a 4 gigabyte or 6 gigabyte. Hey, what is your hard disk size? Oh, I have a 500 gigabyte. Okay, we always use, see that whatever it is, this could be a pen drive or SD card or your RAM on your mobile phone or your hard disk. When it comes to the memory, we always use byte. The giga says how big it is. It is 1 followed by so many zeros is called 1 giga. When I bought my first PC, that had about 256 kilobytes. That means that 000 bytes. Today, what you have is a computer with 64 gigabyte. So for this computer, I paid in 1980 1 lakh rupees. Today you say that's a technology. Forget about no. What I am trying to convey you is that in computer terminology, we talk everything in bytes, not in bits. I don't tell you that, hey, I have so many bit memory. No. We always discuss about in terms of bytes. Same way, when it comes to this software, when you are writing the programming, the memory is organized only in bytes. Now, I can tell that, hey, red, how many bytes you need? I need 1 byte. Blue, how many bytes you need? 2 bytes. Green, how many bytes you need? I need 4 bytes. You can ask. You can ask your how many bytes you want. Am I right? You can ask, or the system itself will give you for your requirement. So don't get confused about allocation. This is called allocation. This we will discuss later, because this should not come to your stop your programming growth. This will affect these informations. Too much of this information. This is actually a language. This should not affect your programming. I'll tell you the difference between various languages about allocation. So I will tell you why the allocation is important. That you need to understand. Even though I'm not going to discuss about allocation, we are not going to use allocation. You should know that why allocation is important. Because if I say one ground, I can construct only a small house. When I have a 2 ground, I can construct a medium house. When I have a 4 ground, I can have a big house. Same way, when I allocate only 1 byte, okay, let us say I'm telling, hey, I want red to be allocated 1 byte. Then the translator will allocate me a location at memory, some number 1000, and he will allocate only 1 byte. That means that 1 byte means how much? 8 bit. 1 byte means 8 bit. So I can write a number from 0000 binary to 1111. That means that 0 to 256. I can store only 0 to 255. Sorry. So 2 power 8. I can store only 256 numbers. I cannot store more than that. Let us assume that I told my translator, I say, hey, for red, allocate 1 byte. He say, fine, take it. Now I say 300 to red. This is wrong. You cannot store it. Okay. If you ask, you buy a 1 ground area, and if you ask your real estate person to build a big house, he will say, sorry, sir, it's not possible. For your land, only this much house is possible. Same way, if I say that, I don't know, I allocate 2 bytes. Then what happened? He will allocate 2 adjacent bytes. See, if you say the 2 ground area, the 2 ground will be next to you. Now 1 ground here, somewhere, no. The 2 ground will be adjacent to you. Then you can construct a bigger house. Same way here, if I say red, 2 byte means 1 byte is 8 bit, 2 byte means 16 bit. So I can store 2 power 16, 65,536 numbers I can store. Same way, if I say that my red symbol going to be 4 bytes, okay, then I will allocate 4 into 8, 32 bits. That is a bigger area. That means that I am allocating you 4 ground. Don't worry about it's a byte. It's a ground. You in your terminology, understand this is a ground. So you will have about 4 ground area. That means that I can construct a bigger house. Here, 2 power 32 is equal to 4 giga. That means that I can store bigger number. So what is a drawback? For example, if I'm going to store only less than 100, my number will be less than 100. If I say red is equal to 4 byte, I'll be using 4 bytes, but actually I'll be using 1 byte. All the 3 bytes is going to become waste. Okay, your memory is going to be waste. So initial days, I'm talking about 30, 40 years back, memory is very, very expensive, not small, very, very expensive. 1 kilobyte memory could be a 1 crore. 1K means 1000 byte. Today you buy 32 gigabyte. That is mean this much memory for 200 rupees. But once upon a time, 40 years back, 1000 bytes cost you 1 crore. Think of it. Those days. So those are the days computer people evolved with the computing system. So that's why today, so many changes. What is the changes? The first change in the computer languages is somebody says, hey, don't tell me red, green, blue. That alone you tell me enough. Don't tell me how much allocate. I will allocate. If you do not tell me that, I will allocate the maximum. Am I right? If you do not tell me, I allocate the maximum. So that is a one programming language. Other programming will say, no, don't tell me. If you do not tell me how much I have to allocate, I will not allocate. I will give you error. Okay, the translator will not do that. So this is called allocation. Allocation is how much memory I want. Second one is called storage. The storage, what I am storing, everything is binary. Storage is binary. But we discussed that 25. Then the translator will convert the 25 into binary. Then if I say symbol, we have alphabets, symbols. We have A, plus, everything we have. All the symbols, whatever you give, all these things are converted to binary and store it. Same way, if you give different type of number system, it gets converted to binary and storage. This is called storage. But initially, during our first discussion of programming, we will not, our allocation will be always 4 bytes. We don't worry about single byte or 2 byte allocation. Same way, we always store decimal. We will not store symbol. We will not store hexadecimal, everything. We will take one thing. The third one is operation. There are so many operations. Am I right? So every operation we have discussed. We discussed subtraction, multiplication, division. We have seen, but there are thousands of operations are there. Okay, each one will have so many things. And then the fourth and most important things what we have seen in yesterday's program is if. If you see your life, if you just think of it, your life, every stage of your life, you are like this because of your decision. Okay, now what is happening is all the programs are basically on decision. After 12th, you could have gone to diploma or degree. In a degree, you would have gone to either arts or science or engineering or medical. In medical, in engineering, you would have taken mechanical or civil or electrical or electronics. Okay, or computer science. In computer area, you would have taken IT or computer science. You could, everywhere you have a branch. In ECE, when you get to the electronics, you could think that, oh, I could have used the hardware or embedded or VLSI. So everywhere you take a decision, the decision make you to the shape. Same way, this computer program, these are all nothing. These are all very easy. You will learn it at no time. The most important thing yesterday, even yesterday's program, a lot of people are confused. I gave you one of the smallest one. Ask you to write in English. Okay. It is because of here what to do. That is what, don't think small. Yesterday, even though I tell you that I've given a small problem, that is actually called loop problem. If you ask every student, those who are learning programming, they will tell you how tough it is to solve the loop. You have to cross the hurdle. That's why yesterday I gave you the problem. Now I'll tell you that what is the major problem here. There are so many languages. So we have a math. In math, we have first symbols, arithmetic. Then we have algebra. Then we have trigonometry. Then we have a calculus. Then we have a statistics. All of them are part of math. All of them are part of math. Okay. But for different problem, we apply different thing. Understood? But ultimately, the answer is same. Some numbers. Okay. Ultimately, you say that whatever you say statistics, you will say finally, hey, how many people today COVID? You put any mathematics, I don't mind. Ultimately, it's numbers. It's same way here. What is happening is, I want to show you one small slide now before I proceed further. Yeah, not coming on screen. No, no, I'm sharing. You should be getting the screen. Okay, I'll go back to the slide a minute because that is I want to show you one important thing. See here, when you make a journey, we walk. We have so many types of journeys there. Okay, think of it. You should know that this is what the mistake we do. Within my house, I walk. In a small street, I go by cycle. A small distance in my area, I'll go by bike. When I go for longer distance, I'll go by car comfortably. Or somebody drives. If I have less money, I go by bus. Okay, or I go by train. So you know that. Let's say from here to moon, or here to Mars, I don't go by bike. I use the car, rocket, plane. So this is the trick here, where everything is having advantage, everything having disadvantage. Understand? One is three of the things. Same way, money, cost. Am I right? Then comfort. There are three: money, comfort, okay, and time. If you go by plane from here to Delhi, I'll go much faster than the train. Am I right? So these three are the trick. Now here also, sorry, it came to the long way. Because I wanted to show that only you will understand. Same way here, we have so many languages, but when I give it to translator, the translator will always give it to numbers, binary. Whatever it is, he will give it to binary, which is going to your CPU. But in that case, why I have so many languages? Why I have Python? Why I have Java? Why I have C++? Why I have C? That's like C means it's like a cycle. Okay. Python means going by plane. So where I am trying to use the cycle, if I use the Python, what will happen? Let us say, for example, I wanted to book a ticket in a movie theater. I know that reservation is going to start at 6 o'clock. But I know that the 6 o'clock start, 6:05, all the tickets going to be booked. You know that. But if you are clever enough, you can write the Python program. The program will watch the site, then look for the particular character or something, screen. Then you can change it and book a ticket. You can write a program in Python in the shortest time. But if you try to write the program on C for that, you're gone. It will take you may not be able to write at all. Okay. The same way, for example, I have a small electronic equipment. And then for the equipment, I want to write a program. If I write it on C, okay, then if I give it to the electronics, the product will, I give an input, I'll get the output. But if I write it in Python, gone. That guy will give it to electronics, the input comes. If you on the switch, the input, the light will become on after a long time. So you should know that, see, all the languages are good, but I'm discussing about today is a programming. What I discussed is 4. You know that I have discussed 4 of them. That is 5 to red, 6 to green, red plus green, to blue. If blue is greater than 10, do something. You have written. So actually, if you see this 4, what I have written is not joke. These 4 are the one which is common for all the languages, nothing more. If you know this 4, You can write Java, you can write Python, everything, programming starting with. But each one will have a slight starting trouble. That is fine. Afterwards, you will be able to write anything. But what I am trying to tell you is that don't do that. Master one programming language, either C or Java or C++ or Python, all are same. There's nothing wrong. So all the computer languages are having these four. One is allocation. Other one is storage. Other one is operation. Other one is decision making. If you know these four, all are same. The only problem is when you give it to the translator, that's a problem comes. For example, today, I got from about a lot of people have sent me their solution for the problem. But unfortunately, no two programs are same. They are different. Not only the procedure, the way in which they have written is also different. Because of that, since I'm a human being, I could understand. But if I give it to the translator, he will get confused. That is the reason all the people, every programming language people has given you one important thing called set of rules. But you know that when there is a rule, automatically you're gone. That is why I am telling you that every language you are trying to learn, whether it is Python, whether it is Java, or whether it is JavaScript or C++ or C, whatever language, never try to understand the rules. The more you read the rules means language. The more you try to understand the rules, you are going away from programming. What you're supposed to do is this. You're supposed to first learn little bit, very, very small amount of rules. What is required? Enough. I'll tell you tomorrow when you are reading C as an example, I'll tell you what you have to learn. Then go to programming. Do lots of programs. Lots. Till what all these things you should thoroughly understand. Even somebody tied your eyes. You should be able to write the program. That level you perfect. So don't say that. See, today you have written a program. You write it once again the same program tomorrow. Till let's say first day you are writing taking 1 hour. Second day you are taking 30 minutes. Third day you are taking 10 minutes. So till you become. So this is what practice. That I'll tell you exactly when you are teaching about C programming. How exactly you're supposed to practice. Where we do mistake. Today, what I'm trying to tell you is that these four are the important. Don't worry about any language beyond the four. And when you are trying to go to the translator, generally, I don't know why we are calling, but we are calling this as a compiler. But actually translator only. It is translator. The translator translates into number. All are same. But the problem is each translator will translate it for different purpose. So as I told you that if you take a Python, it has too much of libraries. I can write things faster. If you take a C, I know that it takes very long time, but I will able to understand thoroughly how the computer works. It is much closer to the computer hardware. So you will understand how if you learn C programming, you know exactly how the programming work. That's why people generally say that you go to C to Python. But there is something else also there. C, generally I prefer C for ECE student, electronic students. Anybody like to do electronics must be master of C, because today every electronic equipment is only C. There's nothing called normal. 99% of the electronic, 90% of electronic students do the mistake they learn C language, thinking that they know C. Nobody wants. This is waste. You better learn C programming. That is why I have titled this program as a C programming. Okay. So second thing is, most important thing is what we discussed, the four are sufficient. One is allocation, and then storage, and then operation, and finally decision making. These four are the one which are the base for any programming language. These four. Then you build up anything, I don't mind. But these four are base. So tomorrow we are going to discuss about even how exactly these four are adapted in C language. Okay, allocation means what, everything on C language. Then we will do enough of programming here. For example, think of a minute. Somebody is trying to build a building. There are two people, person one and person two. Both are trying to build a building. Okay, person one and two is a ground level. This guy is trying to build a 3-story building. This guy is trying to build 10-story building. Who will first reach the 3 stories? When these two people are trying to construct a building, because this 3-story will reach first, because he will put very small base. So he will reach 3-story faster. But whereas the 10-story guy have to put a long base. So he will reach the 3-story later. This guy could have finished in 1 month. This guy could have taken 3 months. But this guy cannot go beyond 3-story, whereas this guy is going beyond 3-story. That is why I have seen everybody in my experience. We underestimate these four: allocation, storage, operation, decision making. These four are the very critical for every programming language. All the computer language depends on these four only. Now, for example, like a driving, when you go to the driving school, even though you might have bought BMW, doesn't matter. The driving school guy will teach you driving only on your Alto or Santro. He knows that once you learn driving on this, you can drive BMW. Same way here, once you learn what is programming, okay, still I know that yesterday I given a problem, nobody could have got it. Okay, not nobody, some of you got it, and most of you, that is a very small program I have given you for your thinking. Please try to do that. That is a very common sense. See, please don't get confused between programming and coding. Programming is common sense. Coding is not common sense. Exactly, you are coding, you should know the language. Programming is common sense. Yesterday, what you gave you is a programming problem. We get a lot of confusion. I told you that's a title also, C programming. I didn't say that C coding. Okay, because I'll tell you that, when I discuss about day after tomorrow, what is the difference between programming and coding, then you will be able to understand it. So please make sure that you solve yesterday's problem. Today also I'll give you another problem as a slightly complicated, but solve it like English only. Don't try to confuse. But we will stick to this 4 and try to solve 40-50 problems. As I told you that this base has to be strong. If you don't have this base, then you do not grow bigger. So don't worry about computer languages. All the languages are the same. If you know one language, so all languages, whether you call Python or C++ or Java or C, all of them are using these 4 methods, and then they are getting translated to binary only. So the one which is going to the CPU or the computer is a binary only. So don't worry about too much. I will give you the framework for C tomorrow. then you will understand. That time itself, you will understand about all the other compilers, because that's why we have taken one sample. We are taking, that's why first day I discussed was what is programming in a common sense. Today, I have given you the idea of how exactly what we discussed yesterday is related to the computer field. Okay. And tomorrow, we will go much depther. Some rules of, since we are taking only out of 4, we are taking only C. What is the rules of the translator? Okay. That is only because of him, they set you set of rules. Then how that guy is going to convert it to number, how you will be executing. So basically what in essence you have to do is that, the thing is that for yesterday's my problem and today I'm going to give a problem for all these things. You write on English. If you know how to convert the English into programming, that is good. That's a perfect. Okay. First of for that, don't make it very easy, light. What problem I given yesterday, what I'm going to give it. Those problems are the one which are going to be good. I told you, there is a procedure to teach you the programming. Okay, that is not the easy part, because I've taken a very tough task. A training is a skill. Programming is a skill. I'm trying to teach a skill through online. Understand? This is not a joke. I can pass you so much knowledge. I can show you so much of PowerPoint presentation. The entire, whenever you will also see all this thing, oh, Balaji given you all these things. It's all waste. You can see any amount of lectures, everything is waste. I want you to make you to write program. Okay, you need to solve the problems. I'll start giving you simple to high tough problems. You should be able to solve it. Never come, and you should be able to comfortably solve it. And I forgot yesterday one tell you important thing. I never like to test you. I'm not here to test you. You have to do self-assessment. Are you comfortable or not? You should tell me, sir, I'm not comfortable. Somewhere I get stuck in the programming. In that case, I will help you how to write the program. But this is a methodology. If you follow the methodology, tomorrow you write a bigger program, that you will get it. So if you don't know how to write a small programs in the right method, you will not get it in the top level also. So the thinking matters here. That is why I am trying to be very, very serious on this programming. It's a very, very skill. It's not a, unless there is your cooperation, you solve the problems. It is very difficult to make you to understand programming. Okay, start doing it in English. Let you don't worry about getting into the. I've not received any problem. No, I've sent it every day by message yesterday. I'll try to solve it out. Why you don't? Not coming in. Okay, that's fine. Yeah, that I'll adjust. It's because I told you, I have to, due to COVID, I'm unable to get any board. I have to, whatever I have it, I'm doing it. Okay, with that, let me formally close it. Then we can discuss about the other things. Okay, let's not